Hey guys, um, it's 8:44 over here at night. Been a long time since I did a stream. I was out on a trip with my mother. Left us really tired, honestly speaking. Got more tired than we had fun, really. So, okay, I'm not sure if I filled you in with the lore, so to speak. So, you remember I was doing that book on concurrency, right? Python concurrency, and all that multi-threading, multi-processing, all that stuff. So I did cover a good portion of that book, and then I reached my favorite part of the book, the part that I was looking forward to the most. It was a chapter on event-driven programming. Now, I assume that uh, the book would cover the concepts of event-driven programming by teaching me, while teaching me Asyncio. Asyncio is kind of the global standard over here for writing event driven applications in Python. Turns out, however, that a lot of the syntax that it taught in that particular book has been not deprecated but removed. So this book must have been at least like 10, 12 years old, and Asyncio itself is like, I think it was released in 2014, 15, aisa kuch to. So a lot of the methods that were taught in that chapter about Asyncio were concepts that are no longer relevant today. So I kind of had to quit on that chapter, at least over there. And it was kind of the most important part I was hoping to learn from the book. So that happened. I was pretty disappointed about that. After that, a lot of the chapters were about like GPU programming and reactive programming and a lot of stuff like that, which is something I don't think I'm going to read immediately. So I just decided that I'll just skip the book entirely and try to study async IO dedicatedly. So I found a book. It's 378 pages long, but I think it's going to be worth it. I know I'm taking way too much time over here, but I like to think at least that it's going to be worth it. Also, I'm going to start with that habit tracker of mine. So I'm going to try to fit in at least an application or two every day so that I'm not just studying all the time. Tutorial hell is a thing. Sorry, pardon. This has been a state ever since we came back from the trip. So yeah, I was on page 40 or something over here. What I'm going to do today is like read uh, the book for like an hour and a half. There's not a lot of code that is being discussed so far, so I won't task myself with just writing notes all the time. I'll just try to read as much as I can until I reach a point where I think I've accumulated a lot, and then distill it into notes. Perhaps I think that sounds like a quick approach, so to speak. I use so to speak a lot, no? I don't know why. So we are starting over here. I hope it's visible. Sure, I'm starting. I'll finish by, I want to say 9:30. Let's see 9:30. Okay, cool. that were paused and let them finish running. Register socket sounds like putting the dish into the oven and just waiting for an unset amount of time for the contents of the oven to be ready. You're not setting a timer over here, or at least I don't think the timer will fit in this analogy. Check for completed IO. Pause associated tasks. Repeat. Add socket for OS to watch. Notifies when socket data is ready. Socket data is ready. And since we are single threaded, is finished in task 1, it gets an IO notification. We'll pause it to say, I'm waiting for IO. Any other tasks waiting to run can run. Time savings of async IO comes in. I end up having such basic questions, right? Like, see, the question that I have right now is, consider a main thread and three child threads under it. Is it true that only one of the four threads can run Python code at one time because of the global interpreter lock? So isn't that the wrong thing to say? That's odd. Processes and threads. Processes and threads. We've introduced the event loop, which is the core of Asyncio applications. Event loop loops forever, looking for tasks. Cool. Coroutines. Eh. Sorry. Mhm. Async, await syntax. To define run coroutines, we must examine how to run coroutines concurrently by using tasks. Creating a reusable timer. Finally, we'll look at the common errors software engineers may make. Think of a coroutine like a regular Python function, but with the superpower that it can pause its execution when it encounters an operation that could take a while to complete. Any other code in that coroutine can run other code. Use async def. As a coroutine instead of a normal Python function. Immediately because you don't have any. But we are creating something very different from a plain Python function. To illustrate this, let's create a function that adds to an integer, function that adds 1 to an integer as well as God, I'm so sleepy. Why am I sleepy? Oh God. Fuck. We get a coroutine object instead. This is an important point as coroutines aren't executed when we call them directly. Important point as coroutines aren't executed when we call them directly. Instead, we create a coroutine object that can be run later. To run a coroutine, we need to explicitly run it in an event loop. So, how can we create an event loop and run a coroutine? In versions of Python, However, the async library has added several functions that abstract the event loop management, convenience function, asyncio.run can use to run a coroutine. So you have to run it in a coroutine. So this is a way of doing it. Asyncio.run. I read this sentence in a textbook about asyncio. Did the author mean to say new event loop or new event? Yeah. Once it successfully does so, it takes whichever coroutine you pass into it. It takes whichever coroutine you pass into it, certain activities, returning the result. This function will also do some cleanup of anything. Will also do some cleanup of anything. The coroutine that asyncio.run executes will create and run other coroutines that will allow us to utilize the concurrent nature of asyncio. So there is one grand coroutine that this guy will run, and that coroutine will be the key to the rest of our program. I think that's what he means. Example we saw in District 2.3 did not need to be a coroutine as it executed only non-blocking. Yeah, is being able to pause execution to let the event loop run other tasks during a long running operation. Awaitable. Await keyword is usually followed by a call to a coroutine. Will cause the coroutine following it to be run. What? Async def main. Yeah, this is just the main function then. Yeah. Your reading station. Okay. Hmm. I don't know why I'm so sleepy. Didn't get this passage from the textbook. Can you explain this with the help of an example? How is this any different from asynchronous code? Wouldn't the callee function also get completely executed and then control will return back to the caller in synchronous code as well? It's an async IO.sleep. I used to use time.sleep. Should I have to use async IO.sleep? Oh, oh god, sorry. Let me run this application. Wait 1 second before printing that. Sorry. I think I'm going to need to sit down and code for this. I think I'll take a small break, Ref. It's a 40-minute stream. I'll come back like in a half hour or something. I'll come back and do the rest. Okay? ये मतलब 10 pages मैं कर लेता हूँ अभी.